Now, let us see the continuation part of implementation of sets, right? Right. So, as we have discussed in the last class, a set cannot contain duplicate elements. So, it inherits all the methods because uh, it is in the collections framework. So, it implements it inherits all the methods which are available in the collections framework. In addition to the methods which are available at collection, it is also implements uh, additional property which it is have is it won't allow you to enter the duplicate elements. There are three different set implementations. One is hash set, and another one is uh, another one is uh, tree set and hash map set. So these are all linked hash map set. These are the three different ways which we can implement the set, right? So as in the last class we have discussed all these things, even the characteristics of the sets and what are the different approaches, and the hash set, what is the process or what way the hash set, linked hash set and tree set implementations are going to be held, and the differences that exist among these also we have discussed in the last class. Now, before going to discuss about the implementation part of the set methods or the implementation of set interface, one should understand the map interface also. Okay, so once we discuss this map interface, and then we will look at it into the implementation of set interface, right? A map is an object that maps the key to value. As you all aware of hashing technique, where with the help of hash function, we'll try to map each and every object which is present in the list with a key generated by the map function. So here also the concept is same. The hash set and linked hash set, these two are implemented based on this map interface. Even tree set also. Okay, so that is the reason why we are supposed to discuss the map interface here itself. A map cannot contain duplicate keys. That means each key can map at most one value. One key is going to map with one object of that list only. Okay, no more duplications, as the way the set contains the elements, right? And the map interface includes the methods for the basic operations, just like set. You can put it. Just put means it is just like add method. Add, you can get, remove, contains key, contains value. These all methods we will see in the implementation part. So and then you just remember that whatever the operations that we can perform on the set, here also we'll have similar kind of operations on maps. Okay, so the Java platform contains three general purpose map implementations. One is hash map, tree map, and linked hash map, as the way which we are going to implement the set implementation using hash set, tree set, and linked hash set. Okay. Okay, as we have discussed in the previous class, hash set implementation, if you don't require any kind of ordering, you'll go with the hash map implementation, where the performance when compared with the remaining two are very high. Okay, when you want an order, you'll go with the linked hash map, where it follows the ordering mechanism of insertion order, whatever the way that the elements are entered into that set. Okay, in the similar way, we will keep the elements in the set itself. So that is the reason linked hash map is maintaining insertion order, right? And a tree map. Tree map. Okay, so in that also we are using binary search tree mechanism, where the left side, the left child is less than the root and the right child should be greater than this one. In such a way, tree implementation, you can imagine that it is a tree implementation. Either the elements are going to be sorted in a natural order like alphabetical order, or you are supposed to define a mechanism through which we are going to order the elements. As I have shown you an example, based on the length of the elements we are going to be sort in the previous examples which we have discussed, right? So in the similar way, priority queues, where we are discussing priority queues, there the priority will be defined based on the length of the element. So in the similar way, you are supposed to define your own comparison mechanism. With that, we will try to keep the elements in an order. So these two are happen in the case of tree set. Okay, so in the similarly here also the mapping process also will be implemented in the same three different ways. One is a hash map, tree map, and linked hash map. Of course, we will see the implementation of these three also. Okay, now why and when to use maps? Okay, maps are perfect to use key value association mapping, such as dictionaries. So the maps are used to perform lookups by keys, or when someone wants to retrieve and update elements by keys. Okay, whenever if you want to, in the dictionary, if you observe, first we'll look at, we are able to look at the words which are starting with A and then followed by B and then followed by C. Okay, so if you want to search for a particular word, so based on that starting letter of that alphabet only, we'll try to search. So in such kind of situations, whenever if your requirement is similar to that, you will go with this kind of approach. Right? Now, some of the example areas where we are supposed to use these maps are a map of error code and their descriptions. Say for example, sometimes when we are surfing on the internet, you might have found an error 404, followed by certain description. Like for each and every code, it is associated with some error message. So whenever if you want to retrieve that kind of information from a list, from a collection, you can use this kind of implementation. Similarly, zip codes and cities, because for each and every village or every place in the country will have a pin code, right? So based on that pin code, we are able to retrieve the name of that place because it is unique. Always the pin code should be unique. No, not two places are having same pin code. In the similar way, whenever if you have the requirement in such a way, you'll go with this kind of approaches. Okay, and a map of managers and employees, because certain employees are working under some manager categories, right? Okay, and similarly, because production manager, sales manager, like that, all the employees who are working in the production will be under the production manager. Sales, similarly, sales team. So for each and every manager will be associated with certain employees. So based on that manager, we can, based on that manager key, we'll try to retrieve the information of the employees. Even we can add, we can delete. So we can perform all kind of operations as the way which we did in the collections of the previous data structures. All right. So a map classes and students, Each class key is associated with a list of students. For example, 4th year section 2. Okay. So this is the class. So this class is associated with 88, 83 or 88 members. Right. So all of you are tagged with the single key. What is it? 4th year second section. So that is the key. So with that, whenever if I want to look for a particular person, okay, Based on that key, I am going to be searching. So these are the some of the example places where we can use these maps, right? Now, a map interface present in the java.utl as stack or linked list or queues or set. These all are available under the package of java.utl. Okay, and it represents a mapping between a key and a value, right? The map interface is not a subtype of collection interface. As you just look at out the map interface of the collections, so here you may not found anywhere the map, okay, but still it is also so. Yeah, that is the reason the map interface is not a subtype of collection interface. Therefore, it behaves a bit differently from the rest of other collection types. Okay. So now you can observe this diagram. Right. So a linked hash map extends the hash map which implements the map interface. Okay. And it extends the sorted map. So there are two types of implementations are there: mapping and sorted map interfaces. There are two interfaces are available in the map. They can be implemented in two different interfaces. One is map and another one is sorted map. Okay, and a tree map is a navigable sorting order. All right. So this is the structure of or the hierarchy of map classes. Right. Now, coming to the methods of the map. So, here the first one is put method. Put method is just like add. Here, when you want to add an element into that, we are supposed to add element and as well as the key for which it is associated. So, we are supposed to add two values rather than single one. Whereas if you want to add an element to the set, directly you can add. If you want to add an element into the stack, directly you can add. But here, along with the element, you are supposed to add the key also. So that is the reason here we will find two different parameters. One is K and another one is V. K represents the key and V represents the value. Right? And put all. So add all. So all the elements. So all the elements which are present in one list is going to be added to the another list, as we have discussed in the linked list. L1 dot add all of L2. So what happens in that case? All the elements which are present in the linked list 2 is going to append at the list 1, end of the list 1. So in the similar way, here also the put all inserts all the entries from a specified map to this particular map. That means for whatever the map that you are going to apply this put all method. Okay. So similar to the linked list example which we have discussed. Of course, we will see once again the implementation of put all method in the implementation of the map interface. Right? Put if absent. Okay, here some of the methods we are not used frequently. Only few methods we can use. Inserts and the association if the key is not already associated with the value V. As I told you, key should be unique. It won't allow you to enter duplicate key into the collection. So whenever if a key is absent, it is allow you to insert. Okay, and get key. Simply it returns the value associated with the specified key K. Okay, that means if you want to retrieve an element from it, where suppose if you are considering stack, if you want to insert an element here, you are supposed to use push method. If you want to delete an element from it, you can use pop method. Right? Similarly, if you want to retrieve, just like the peek method, peek method displays the topmost element either in the stack or in the queue, which we have discussed in the previous class. So here also, with the help of that get K, whatever the K means key, whatever the key that is associated to the value, that particular item is going to be retrieved with the help of object, get method. Get our default here it is an one of the important method which we are using in the map interface. So if you observe the functionality of this particular get or default method, it returns the value associated with the specified key. It returns the value associated with the specified key. If the key is not found, it returns the default value. If the key is not, as in the C++ and Java, while discussing those two languages, we may discuss the default arguments. So what is the job of the default arguments? If you supply, if a user supplies an argument, so that will be considered as the value of that particular argument. If the user forgot or intentionally, if he was not submitted or any value, automatically the default value will be considered as the argument value. So in the similar way, here also, whenever if a key is not found, it returns the default value. So that is the reason you can set a default value, because without using key, you may not retrieve the element, you may not insert the element, you cannot perform any kind of operation. So that is the reason whenever if you forget something, okay, we'll use these kind of methods. Okay, contains key, contains value. It is just searching mechanism. Whether a key is present in the list or not, you can search with the help of contains key. Similarly, value. If you want to search for a particular value, whether it is present in the list or not, we'll use the method contains value. Replace. So replace the value of k with the new specified value of v. Sometimes we have already stored an element, but we want to update it. So in that case, what happens is, we'll supply the same key with a different value. So in that case, what happens is, whatever the previous value that exists, that will be overridden. So that is what we can call it as an updation. So that can be done with the help of this particular replace method. And similarly, for deletion, remove. You can remove the k. So here k stands for key and v stands for value. Don't forget it. Okay. So if you want to delete the entire entry, you can use the method remove k comma v. If you want to remove only key, okay, you can go with the remove k method. And another important method is key set. So it returns a set of all the keys present in a map, just like it returns a set which contains the keys. Okay, and similarly, values. It returns set of all values present in the map. Entry set. It is another method, important method. Entry set returns a set of all key value mappings present in a map itself. So these are all the different methods which are available at map. If the objective of the map, if we observe, so simply it maps a key with a value. So that is the purpose of this particular interface. So now let us see the implementation parts of the set and as well as the map. Okay, let us look at about this particular example. This code illustrates the implementation of set. Here, don't worry. This is the code may be huge, but here I was implemented it for strings and as well as integers. So that is the reason it may look with like a lengthy program, but the purpose is very simple. Okay. Now let us see how to declare a set and how to add elements into that and how we will retrieve all the fundamental operations on sets. So once again, you can recollect, a set will not allow you to store the duplicate values. That is the main important point. And what are the fundamental operations that we can perform? You can add an element to the set, you can delete, okay, you can search for an element. And in mathematics, if you observe the set operations, union, intersection and difference, these are the three basic operations in mathematical perspective. So we will see all these implementation of all these methods in this particular program. Okay, so now set, as you know, set is an interface. So you need to have a class that extends that implements this particular interface. So that is the reason here I was consider hash set. has set class. Okay, as we have discussed in the hierarchy of the classes and interfaces in the collections framework, right? Now here I was created an object for the set class name as vowels. Okay, that will be created with the help of has set class. Okay, and it contains, the set should contain the information in the form of strings. Okay, now that means you are supposed to store only string values, as we have discussed. Type safe. Okay, so here if you specify the type, you are allowed to store only that type of information rather than, I mean, it won't allow you to store other than this type. Okay, now vowels dot add a. So for the first element which I am going to add to the set is a, and next I will add E, and then I'll add I. So here I was added 3 elements into the set. One is A, E, I. Okay. So let me check whether it, as I told you, set will not allow you to store duplicate values. Okay. Let me check whether it is correct or not. Vowels dot add of suppose if you give E. Okay. Let us verify whether it is correct or not, whether it generates any exception or not. All of you understand? All of you look at this particular one. Vowels. Sorry, spelling mistake. See, it shows it was allowed in this, but it is not correct. Let me check what is wrong with this. Here E is a duplicate value. It was already there in it. It is supposed to generate an error message. Okay, so this point you just remember, this is an error. Definitely, I'll clear this doubt later. I will verify and I'll let you know, because sometimes the compilers will also treat the codes in different ways, but it is the basic characteristic of the set. It won't allow you the duplicate values, but we need to verify it, right? Initially, but this particular compiler which I am using shows it as a correct value, but it's not correct. I'll check it out and I'll let it you know. Okay. Okay. Then after this, I would like to print the values. So even though, see here you can observe, no, it shows the correct value. Even though here I would like to enter the another element as E, but when I try to print the elements, even though it allowed you, but it won't be displayed in the set. Actually, what we are expecting after inserting this second E, the set should contain A, E, I, E. Okay. So if it displays in such a way, probably this compiler is wrong. But even though it allows you to insert the element, but while displaying it displays only A, E, I rather than A, E, I, E. Am I correct or not? Yes, A, E, I only it was displayed, because anyway it allowed, but it won't place it in the set because the element is already exist. The similar element is already exist. That is the reason it was not placed. Suppose instead of E, if I write some other element like X, let me check. So now you can understand AEXI. So this particular element is inserted in it. So now it is clear that even though it allows you to insert element, but whenever if you enter the similar element, it won't be displayed. Displayed in the sense internally, it won't allow you to store it. Okay. Right. Okay, done. So next, here I have created another object to the set. Here the object name of the first set is vowels. Now I'll create another set with the name called set. Okay. Here I was added two elements to this. One is O and another one is U. Now I would like to add this particular set to the previous set vowels. Okay. For that, I need to write the statement vowels dot add all of set. Okay. So add all method adds all the elements which are present in the set named as set 1. Sorry, here can I write set 1 so that you are able to differentiate, because otherwise the pronunciation will be the similar. Okay. Now the elements which are present in the set 1 are added to the set vowels. Okay. Now all the elements are printed, so you can observe the because this is the previous one, right? A E I O U. So the elements which you have inserted will be added to the vowels set. Vowels set, right? Now after that I was cleared the elements which are present in the set 1. If you want to check it out whether all the elements are cleared or not, let us check. After clearing, we'll just try to verify whether it was cleared or not. We just tried something, otherwise we cannot understand. Now you can observe set elements are here, the set is empty. So the clear here the clear method, it clears the all the elements which are present in the set 1. Okay, right. Now system.out.println letters set size is equals to vowels dot size. So the size method will display the size of that set. That means whatever the number of elements which are present in the set, it just counts. Okay. So now here we will have 5 elements in our set vowels. So that is the reason it displays the size as 5. Okay. And then vowels dot clear. That means all the 5 elements are deleted. So here the same which we have here we have tried to insert the duplicate element into the set. Here we I tried the same. Unfortunately, we have discussed it previously, right? So this is the code for checking of entering duplicate value into the set, and then we'll try to print out it. Okay. And this is the another statement, contains method. As you all aware of that, contains method meant for searching for an element whether it is present in the list or not. If it presents, it returns the true value. Otherwise, it returns the false value. Okay. Now you can observe the code here. True. True means the element is present in the list. What is the element which you are going to search? E. So anyway, it is present in the list. Okay. All right. Now let us talk about mathematical functions. Here we will call it as a bulk operations. Okay. What are the mathematical operations that we can perform on the sets? Union, intersection, and difference. Okay. Now let us see the implementation part of all these three important methods, operations. Right. Here I has created a set A of type integer using hash set class. Okay. And then A dot add all of, here I was creating an array list. Okay, with the elements 1, 3, 2, 4, 8, 9, 10. Okay. So all these integer elements are added to the set A. Okay. Similarly, I has created another set B For that also I have added an array of elements. These are the elements which I have added to the set B, because for performing union, intersection and in difference, we need to have two sets. So that is the reason here I was created two sets with the two different values. Okay, so first union in the sense it joins the two sets. Okay, suppose set A and set B, the result will be, the resultant set contains all the elements which are present in A and as well as B without duplicate values. Suppose here in our case we have to find out 1 is present in both the sets, 3 is present in the both the sets, and 4 is present in the both the sets. Similarly 0 is also present in the both the sets, and 5 is repeated 2 times in the set B. You can observe. So even though 1 3, here also 1 and 3 is present, and here also 1 and 3 is present, and 4 0 is present in the first set, and 0 is also present in the second set. So while performing the union operation, so you are getting a unique values rather than duplicate values. So in order to perform the union operation, union dot add all of B. Okay, here union is the new set. It is the name of the new set. If you want, you can make it as a C. For better understanding, I wrote it as a union. Okay, union dot add all of B. Okay, initially the union object is stored with the values which are present in A. Which is present in A? What is A? It is a set. What it contains? Okay, 7 elements, 1 3 2 4 8 9 and 0. So all these elements are stored in union itself. Okay, and similar, because we need to perform some other operations on A and B, that is the reason I am not using. Otherwise, if you want to perform only union operation, instead of creating all these things directly, you can write A dot union, A dot add all of B. In that case, what happens? All the elements of the B will be added to the A. So the set A is going to be modified. So I don't want to modify the set A because I am supposed to use it for the subsequent steps. So that is the reason here I was created another object union. Okay, so after applying this operation, I'll print the values of set union. Here you can observe that 0 1 2 3 bulk operations union. Union of the two set is 0 1 2 3 4 5 7 8 9. Even though the 1 is presented in the both the sets, 3 is presented in the both the sets, and 4 is present in the both the sets, even 0 also. So even though these 4 elements are repeated in both the sets, but in the resultant set you will find only 1 and 3. Okay, so because it is also set, union of the two sets are also be set, the basic characteristics of the set is it won't allow you to store the duplicate values. So because of that reason, even though the set A and set B contains the repeated, same elements, in the resultant set you will find only 1 entry rather than 2 entries. Okay. Similarly, intersection. Intersection is also, here I has created another object with the values of A. So the intersection set contains initially whatever the values which are present in the A set. Okay. So here intersection means which finds the common elements which are present in the both the lists. Whatever the element which is present in the both the lists will only be displayed. Okay, so in our example, what is the element? 0 is present in the first set and 0 is present in the second set also. Similarly 1 and 3, okay, and 4 also. So in the resultant set, what we are observing? 0 1 3 4. So let us verify whether it is correct or not. Yes, intersection of two sets is 0 1 3 4. So what it shows? It displays only the elements which are present in both the sets only. Similarly, difference. Okay, difference A minus B, set A minus set B means all the elements which are present in A minus elements in B. That means suppose if the common elements are present in A and B, those elements will be deleted. The remaining elements, that means which are not common in set A only, will be displayed. Okay, so that is the output. So here you can observe that these are the elements which are common in both the sets. So whatever the remaining elements other than this 0, 1, 3, 4 are present in the list 1. List 1, 0, 1, 3, 4, these are the common elements. So we can delete all these things. Whatever the remaining elements, 2, 8 and 9. So these are only the elements which need to be, which is supposed to present in the resultant set difference. Okay, so this is the output. So this is the way we can implement the set implementation. We can perform all the operations like this, right? The same example we will see by using iterator also. Okay. Right. Is it visible to everyone? My screen is visible to everyone? Because in the last class we have faced a problem. Sometimes it was not shared. Any one of you? Is it visible to everyone or not? Okay, okay, done. Right. This is the another way of implementing the set. That means not another way, using iterator, how we are going to be implemented. The same process can be used for implementing linked list, implementing say stacks, queues and all. The iterator, as we have, as I told you in the previous classes, iterator is just like a cursor. Just like a cursor. Suppose initially always it is supposed to start at the beginning of the statement. When you move on to the next, all of you observe the cursor position. Initially at the beginning of the statement, like that it is going to be blink. When I move to the next, it will be moved to the second position, third position, fourth position. So in a similar way, okay, whenever if you want to move the positions from beginning to the end, we'll use the iterator, because all these are collections. Collection means a group of elements together will be represented as a single unit. So in that group of elements, when we are traversing from beginning to the end, we will also take the help of iterator. Okay, so now let us see how it will be implemented with the using iterator. The same example, right? But I was a little bit minimized the complexity. Here you can observe that I was created a set with the class object as set, because set is an interface, you cannot implement it directly. Okay, so here I was added 5 elements for I equals to 0, I less than 5, I plus plus, set dot add of I. Initially 0 will be added, 1, 2, 3, 4. Okay, so from 0 to 4, total 5 elements are added to the set. Okay, now iterator. Iterator is equals to, so all of you remember this syntax. Iterator is equals to, so the object name, whatever, you can specify your own name. It need not be always an iterator, but this is the interface name. It should be the same. Okay, then set dot iterator. Okay, whatever the collection which you want. Suppose if you want to apply the iterator by using iterator, you want to retrieve the elements of a stack. Here you can specify the stack object, like linked list object, queue object, okay, map object. So whatever the collection, so that for that you are supposed to create this. Okay, set dot iterator. Now this iterator object is used to retrieve the elements, is used to move the cursor position in the set. Okay, now while iterator dot has next, as we have discussed, has next, the iterator, while discussing iterator methods, as explained, has next method is used for finding whether some other elements are present in the list or not. Because if this is the last element, when you apply the has next or when you apply some other operation on it, it is unable to perform. So that's why always it need to verify whether has next by using the has next method. Okay, int I is equals to int iterator dot next. Just simply I will print the value. By using iterator, I will try to fetch the element from the set, and that element will be placed in I. That element will be displayed. So in this case, what we are expecting, iterator dot next. So what will be the current element? Iterator is moved to the next position. What is the current position which it points? As I told you, always it is at beginning. Okay, when you execute this statement, iterator dot next. So what is iterator dot next? All of you, are you able to see my cursor or not? Initially, always when you write the statement like this, okay, automatically this iterator of the points the beginning of this elements of the set. Okay, all right. Say for example, here I will write the set itself. What are the elements which are present in it? 0, 1, 2, 3, 4. Okay, so these are the 4 elements which are present in the set. So whenever if you write the statement like this, automatically this iterator object points the beginning of the set. That means before 0. If you write the statement iterator dot next, automatically it moves to this position. So whatever the element which is present before that will be supplied to the I. In this case, 0 will be assigned to the I. So the same is printed here itself, right? So like that, we'll try to fetch the elements using iterator. We'll try to fetch the elements of the set using iterator. Okay, we'll retrieve all the elements, and those will be one by one we can extract, and that will be assigned to I. The same will be printed. Like that, this process is repeated until the set it reaches the last position. Whenever if it returns the null value, that means no element is present in it. So automatically the loop is going to be terminated. After that, I would like to cross check whether it displayed all the values of the set or not. You can check here itself. 0, 1, 2, 3, 4. These are the elements which we have retrieved with the help of iterator object, and these are the original elements of the set. Okay, so what it indicates, with the help of that iterator we can retrieve all the elements. Okay, just you can imagine it is a cursor. So this is the code. Actually, here I wrote the code for removing the odd elements and all. Okay, so this is not an issue. Okay, anyway, I will explain. Iterator is equal to set dot iterator, while iterator dot has next. Okay, int x is equals, we will retrieve the first element from it, and I will verify whether it is even number or not. Okay, if it is even number, I just move to the iterator dot remove. Whenever the even number is present in the list, I will try to remove it. Okay, so now in our case, what are the even numbers that are present in it? 2 and 4. So in these two cases only, this particular statement will be executed. Remaining all the cases, the loop is repeated empty. All of you understand? The resultant set 1, 3. 0, 1, 2, 3, 4. Anyway, 0 by 2, it also results it as a 0. Okay? Alright. So after that, we have printed the elements which are present in the set after removing the even numbers in the set itself. Alright? Okay. So in such a way, we can use, we can implement the iterator method in the by using iterator object, we can retrieve the elements into the elements from the collection. So these are the two different approaches of the set implementation. Now let us look at the map implementation also, which is also a simple program. We just discuss so that it will be completed. Okay. Yeah. Yeah, you can unmute yourself and you can ask. A5. Or even you can type the message also. Okay. Anyway, we will see in the next class the implementation part of map and other methods. Anyway, I'll share all these programs to you in the group itself. Now you can ask any queries if you have. I'll stop sharing. Yeah. A5, A5 or A2? Who raised a hand? Or even you can type your query in the chat box also, no issue. Lokesh, are you present in the class or not? Lokesh. Lokesh. Any queries? Any queries? Mohan Babu sir, can you announce the absentees? Mohan Babu sir.
They will be sorted soon, sir.
Okay. So you need some more time to sort out all these things, right?
Very difficult to sort out.
Okay. Any queries? Did you receive yesterday's documents? Have you gone through it? Any one of you, please respond. Jay Prakash. Jay Prakash. Jay Prakash. C4.
Sir.
Are you able to understand?
Sir.
Do you have any queries? Do you have any queries? You can speak. Prakash,
Sir.
you have any doubt?
No, sir.
No. Did you gone through the documents which I have supplied in your group?
Yes, sir.
Okay. Okay. Anybody else? C2? 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 Are you there or not? C2? C1? C1? C1?
Sir.
Are you able to understand?
Sir.
Why you try to join with your name rather than your register number? Yesterday you were joined with your name. Today also you try to join with your name.
I log in with my Gmail account, and then after entering, I should rename it, sir.
You can change while joining also. You can change because it creates difficulty for us while admitting you. Okay.
Okay. Okay. Sir.
Do you have any queries?
No, sir.
No. Did you gone through the documents which I have supplied?
Yes, sir.
Okay. So I'm going to end the session. Meanwhile, I just a small announcement. Monday we will discuss about the generic classes. After discussing the map implementation, we'll go to the discussion of generic classes and generic methods. Of course, we have already implemented generic classes and generic methods in the examples of linked list and all. Okay, you need to prepare something about just definitions and what is the advantage of generic classes and generic method, because tomorrow in the next class I will ask some of you to answer some questions regarding generic classes and generic methods. Okay, hope you all clear. If you have any queries, I'll wait for another 2 minutes, otherwise I'll close the session. No queries? So shall I close the session? Any one of you? But without giving your concern, you are left from the meeting. Huh? Okay. Okay. So now I will end the session and we'll meet in the next class. Thank you.